The first thing you'll want to do is to download the data file. Now, I typically do this by heading over to Files and then searching for Files. I'll search for Alumni here, and we're going to go to AlumniTableauPractice. So I'm going to download this. It'll go into my Downloads folder. And then what I will do once it's downloaded, I will go ahead and open that up in Tableau. Now, the way I do that is to go to the text file from the splash screen and to open up AlumniTableauPractice. Now, the data is all ready to work with, so we can immediately head over to Sheet 1. Now, for Sheet 1, we're asked to make a plot, a geographic plot, of the average value of the number of years that alumni have donated to UT, which is contained in the field Years to UT. So we want to make a map, and then we're going to put some labeling, some color coding. It looks like we're going to exclude some states, so let's get started with that. So let's start out by making the map, and what I typically do is go down to latitude and longitude and just double click so that it gets into the appropriate fields, the columns and the rows section. So this will bring up a whole map of the world, and then we need to say what level of detail we would be interested in looking at. And in this case, I want to be looking at it on a state-by-state detail, so we can go to State Code and bring that over to Detail. And that'll bring up a map of the United States. Those are the states that are represented in the data. And where do we go from here? Well, let's look to see what we're requested to do. So number one is that we only want to include states that appear 30 times or larger. So Alaska is in the data, but maybe it doesn't appear all that often. Let's go ahead and build a filter so that we only see various state codes. So I'm going to drag state code to filters, and I'm going to say condition, I only want the states that appear at least 30 times. So building this filter on the state code, we want the count to be at least 30. We'll press OK, and that'll zoom in actually on the continental United States. Hawaii and Alaska didn't appear in the data often enough to make the cut, and here's what we got. So what do we want to do with this map? How are we color coding? How are we labeling? So we're looking at the years to UT field, and specifically the average value. So we're going to color code these states and then label the states based on the average value. So let's go ahead and take the value, or the column, years to UT, move that into color, and also move that into label. We're going to use that information for both. Alright, so number one, it's looking at the sum of all the values in the years to UT for each state. That's not what we want. We want to measure the average for both of these. So we'll measure the average. And first thing we note is that there's too many digits. So we can control the number of digits by editing this in the format of our label here. So label is this T. If we right click and say format, that'll bring up a bunch of things that we can control. We're going to control the numbers. Specifically, we're going to go to number custom and just decrease the number of decimal places by 1. Alright, so we like that. The next thing we're going to do is to edit the colors. So what we're going to have is a green-blue diverging scheme. We're going to pick the center at 3.5. That's the average for the people living in Tennessee. So we can go right-click on the colors field. Doesn't look like that's the right place, so we'll click on the colors themselves, onto Edit Colors, and we'll go and hunt for that green, blue, white diverging. And we'll go into Advanced because we want to set where that center point is. We're going to center that at 3.5. So we'll click OK. We'll go back. You'll notice there's a slight difference in the colors that appear in your target plot than the colors that appear here. And the reason why is that when we edited these colors, we didn't force it to use the full range from dark blue up to dark green. So I'm going to say use full color range, and that's going to highlight the extremes a little more. So that one is done. We can call this plot 1, or we can just rename it to be map of average number of years to UT. Let's move on to plot 2, and this one's actually pretty involved. what we want to look at is the percentage of the graduates that graduated in each year, the percentage of those that have made a donation so far to the University of Tennessee. So the plot actually looks like the percentage gets smaller and smaller as we move into the present era, and that makes sense. These alumni over here haven't had enough time to really build up the wealth to want to donate back to UT. So we're going to make a time plot looking at the percentage of the alumni that graduated in 65, 70, etc., who have made some sort of donation to UT. So the first thing that we're going to do is we're going to create a field that lets us know, yes or no, if an alumnus has or has not donated to UT so far. So we can go over into analysis and create calculated field, and I'm going to call this ever donated. And the way we're going to set this up is with an if-else statement. So we have columns for lifetime gift to Haslam, UT, and then also deferred gifts. Basically, you can have my money when I die, also to Haslam and UT. And if any one of those four values is bigger than 0, that means that they count as having donated. So we can say if, and then in parentheses, and we can just drag the columns that we want to reference. If deferred to Haslam is bigger than 0, or deferred to UT is bigger than 0, or the lifetime gift is bigger than 0, or the lifetime gift to UT is bigger than 0. So we close off that parenthesis. It says it has errors because we haven't finished it yet. After that parenthesis, we need to say then. So if this is true inside the parentheses, then what? What do we want the value of ever donated to be? Well, we want that to be yes. Otherwise, we want it to be no. And then what we do is we finish off the if statement with an end, and we click OK. And we see that now ever donated is something that we can play around with. All right, so what we want to be doing is we want to be measuring something about ever donated on the vertical axis, basically the percentage of alumni that have donated. So let's move ever donated to rows. That's our up and down axis. And we're going to go ahead and move that to the columns as well, because we're interested in breaking it down in terms of yes and no. Now we'll come back to that in a second, because there is one more calculation that I need to complete. I need to look at the graduation date. And if I head back to the data source, you'll find that the graduation date is stored in a funny format. It's numerical. The first 4 digits, though, are the graduation year. The last 4 talk about the graduation semester. So we actually need to go and create one additional calculated field. I'll call it grad year. That essentially takes the degree 1 grad date, divides by 10,000. That way the integer part of the number is the graduation year. The decimal part is the semester information that we don't care about. So if I just say, let's take the floor of that, that'll round down to the nearest integer, and that'll give me the graduation year. All right, so what I want to see is graduation year from left to right. I want to make a time plot, so I'll drag that into the columns. Now, you'll notice that it's treating it as a numerical value, and we've encoded it to be a numerical value, but we really want to treat each year separately. We want to have them stand on their own, kind of like the levels of a categorical variable. So what we can do is we can change this field to be a dimension, what Tableau essentially refers to as a categorical variable. And once I do that, we're going to be treating each one of these years separately. Now, we see an issue that we have graduation years all the way down to 0, so that must mean that graduation year just didn't quite exist. So let's actually go ahead and add in a filter on grad year. Right-click on grad year up in the columns, and we can say, well, let's just start out with 1948, because we are instructed to consider only years 1948 and later. Okay, so I'll click OK. Isn't quite looking with the plot that we're targeting yet, so there's still stuff to do. All right, so what we're really interested in measuring going up and down in the rows dimension is the percentage of those alumni that graduated in a particular year that have indeed donated. So what we need to do is we need to say, well, we need to measure something about ever donated. Clicking the arrow and going to measure and count, well, we essentially want to count up the number of people that have and the number of people that haven't. And here we get something that is starting to look a little bit nicer, but notice it's just counting up the number in each graduation year instead of the percentage. So we need to actually go back to the count in the rows field and actually say, well, quick table calculation, we want the percentage of something. We'll choose percent of total. So we'll do that, and this changes to percentages, but it's the percentage of all of the people in the data set. We need to specifically say, I want the percentage of people that graduated in 1970 who have donated. I need to do a little bit extra and say how those percentages are being calculated. So I'm going to say compute using, and what do I want the percentages of? Well, I want the percentage of people that have and haven't donated, so I'll choose ever donated. Now, I have two side-by-side plots because this is looking at the fraction of people that haven't donated, and this is looking at the fraction of people that have. Well, this one on the right is what I want. I don't want the one on the left, so let's hide it. Just right-clicking on no, we can say hide. And now we've come up with the intended plot. All right, so we can rename this sheet. So percentage that have donated by year. And we can move on to plot number 3. Plot number 3 is going to explore gender and major. We're going to make a bar chart showing the percentage of each major, marketing, statistics, accounting, whose graduates are female. So let's build the basic bar chart and then tweak it to get to the target plot here. So essentially what we want to do is look at a bar chart showing the frequency of majors, specifically the genders within each major. So from left to right, basically each bar is going to be a major. So I'll go ahead and move into my columns all of the majors, so going left and right. But I immediately want to restrict what majors I'm looking at because I only want to look at the top 15 most common majors. So I'm going to right click and say filter because I don't want every major, I only want some. I'm going to go into top, and what I essentially want are the top 15 most common. So I can say, well, give me the top 15 of the degree 1 major, and that'll restrict it now to the 15 most common majors in the data. All right, so for each major, what do I want to do? Well, I want to calculate something about gender code. So let's go down to gender code here and add that into the rows label, the vertical axis. So we see this F, M, and U, U for unknown, M for male, F for female. We're interested in the percentage of females here. So let's count them up. Let's measure something about this. Let's measure the count. And this lets me know the total number of graduates from each one of these majors. So I want percentages though. So I need to break this down by gender. Now, in order to get the percentage of a major that's male, female, etc., I actually need to make sure that in my columns tab, I have gender as well. Once I do this, what you'll notice is that right now we have one bar chart, but if I move gender code up here, I will get 3 bar charts, one for F, one for M, and one for U. Now, I don't need M, so I can hide it. I don't need U, so I can right-click and hide that. I'm just looking at the chart for females. Okay, so this is the number of females in each gender that have graduated. We want the percentage, so we'll go and do a quick table calculation and say percent of total. Go back and say, how are we computing those percentages? Well, not the percentage of everyone in the data. That's the default presentation. We want to know the percentage of people who had each gender, specifically female. So we'll choose gender code. And now we're given the percentage of graduates that were female. Now, a bit more, we're going to sort these bars from biggest to smallest. So our 2 friends up here, the sorting ones, let us go in either direction. I also want to label each bar by the total number of individuals with that major. So I can go back to degree 1 major and say, let's label something. What do I want to label? Well, I just want to measure the number in each one of those majors. And then I also want to color code. So a little bit confusing to see 164 and 2103 right next to each other. These bars are about the same height, even though we know they're measuring different things. Let's go ahead and add in some color as well to make it clear that these are telling us the total number of individuals. So we'll go to degree 1 major, put it into color. Not a very useful color right now because it's just giving every single major its own color. We want to color code by the number of people in those bars. So we'll go and measure the count and color code by those counts. Now the last thing we want to do is to add in a horizontal bar for the average. So overall, what percentage of the graduates in the College of Business are female? Well, if I want to add in a vertical or a horizontal line here, we want to do something to this axis. So I'm going to right click and I'm going to say add a reference line. Now what I want to do is to look at the average value, so that's good. But I want this for basically the entire table. Don't do this for each major one by one. Let's do it for the whole table. So let's actually label this by the value of the average. Notice how we have these overlapping labels. That's because it's just literally trying to tell you what the value is for each one of those bars. If we go to entire table, well, now it'll take the average for everything that it sees here. Now the last thing we want to do is be able to read these majors here. Notice how these labels are rotated. So if we want to change anything, we right click and rotate label is in there. That'll let us see what each of these majors are. So we can rename that. So percentage female in each major, and move on to the next plot. Now the next plot wants to look us at the distribution of the lifetime gift to UT versus fraternity or sorority membership. But specifically, we want to make sure that those fraternity sororities appear at least 50 times in the data. So once again, we want fraternity sorority to be going left and right. That's going to be our column header. So let's go ahead and add in fraternity sorority left and right, and immediately right click and select filter because we only want the ones that appear at least 50 times in the data. So going to condition, we want the ones in fraternity or sorority whose count is at least 50, and that will narrow down the field a bit. All right, so what do we want our vertical axis to be? Well, that's the lifetime gift to UT. So we can drag that to rows and then tweak it a bit. Right now, the default presentation is to give us the sum of all the donations from each fraternity or sorority. And I feel like the best way to get a box plot from here is to click on the Show Me and to click on the box plot icon. Now, when we do that, it collapses the plot into just one box plot. It's actually showing us the distribution of the total amounts that the 15 fraternities have donated. That's not what we want. We want to break this down by each fraternity or sorority having its own bar. So we'll say, all right, drag fraternity sorority back to column so that each one gets its own bar. But we're not seeing the individual values. We're seeing the sum once again. How do we get each individual value? Well, we go to analysis and uncheck the aggregate measures. And now we have each individual donation listed. Now, because we have a huge range of donations, this isn't a very useful presentation. And in fact, we want to change the vertical axis to be logarithmic to get a better level of detail. So we'll right click on that axis and say edit axis. And we can say logarithmic. All right, so now 1, 10, 100, 1,000. We see a lot more detail. However, there's still somewhat of a problem. There's still a lot of people in these fraternities, sororities that haven't donated yet. And if we go and look to see what else we wanted to do with this plot, well, we wanted to include values of lifetime gift to UT that are only larger than 0. So we need to create a filter on the lifetime gift, drag that to filters, and let's put in a 1 for the minimum amount. Once we press OK, all right, we see the top and the bottom of these box plots, so we're good to go. The last thing that's requested is that the box plots are sorted by median lifetime gift to UT. Right now, I guess it's alphabetical. we need to do a sorting of fraternity to sorority. So how would we sort? Well, we want to sort on fraternity to sorority, so we'll click on that, right-click, and say Sort. So how do we want to sort it? Well, we want to sort based on some sort of field, specifically the lifetime gift to UT. So we'll click Field. The field name is automatically selected for us. It kind of anticipated that. And the way we're going to look at it is by the median instead of the total sum of all donations. So if we want it to go from biggest to smallest, we'll do descending. And there we go. So lifetime gift to UT by Greek, let's call it. And we can move on to the fifth and final plot, essentially making side-by-side box plots based on the wealth engine rating of the alumnus. The wealth engine is someone's guess, a third party's guess, for how much an alumnus could potentially give to UT if they're feeling generous. And we're interested in seeing, all right, how well does this wealth estimate do its job? Do people with higher wealth estimate ratings actually end up donating a lot more to UT? Let's find out. So from left to right, what we want to see are the values of WE. Notice there's a lot of levels here, and in fact the target plot combines a lot of these levels. Well, let's make the side-by-side box plots first and then do the combining of the levels as requested. So what do we need to see? Well, we want to see the distribution of the lifetime gift to UT as our vertical dimension, up and down. So I'll move lifetime gift to UT to rows, but that's a bar chart. We want to see box plot, so the show me and the box plot icon is what we want. Now, we don't want a box plot giving us one data point per level. We want to see every single alumni's donation and just have that broken down by values of WE. So to make side-by-side box plots, we just drag WE once again to the columns, and that's going to give us 1 for each unique value of the wealth estimate. Now, only one number is plotted. Right now, it's the sum of all the donations of people that lived in this particular wealth rating. If we want the box plot itself, we need to go to Analysis and uncheck Aggregate. So same problem as the last. We should really look at this on a logarithmic axis. So Edit Axis, go to Logs, so we get a better level of detail. And then also we want to exclude zeros. It's not very interesting to us when there's a 0 here, so we're going to add in a filter based on the lifetime gift, and we'll make sure that the data that's being displayed correspond to at least $1. That makes nicer box plots. All right, so we have a box plot of the donations for each one of those wealth ratings, and the target plot only has 4 box plots here. So some of these levels got combined. So number 1, let's hide the group that's unable to evaluate, this WEZ, and the nulls. So holding down the Command button on a Mac or the Control button on the PC, you can click as many categories as you want and just say exclude. I don't want to see those. Now the next thing is we want to combine levels into like one that's 500,000 plus. Looking at these levels, this is 1 to 5 million, 1 to 2 million, 500,000 up to 1 million, and that's essentially what we want to be looking at. So we want to combine these 3 levels into 500K plus. So I'm going to do that same trick where I keep the Command button on a Mac or Control button down to highlight these 3 groups, and I'm going to take the little paperclip to group them together. So let's combine them all, and what I want to do is right-click on that label and say Edit Alias. And I just want to say 500K plus. Give it a new name, one that's easier to work with. So next level, 1,000K to 500K. So it looks like these 2 right here need to be joined together. We'll group them together. And then rename that alias, edit the alias. Or 100K to 500K. That's what I wanted. And then we want a 50 to 100K. That's just this one actually, so we'll just rename this alias 50K to 100K. And then everything else we're going to lump together as less than 50K. So we'll paperclip it and then say less than 50K. All right, almost there. Tableau, though, has organized these box plots from left to right based on alphabeticalness. And in this case, we want to go actually from smallest up to largest wealth rating. We need to sort on the wealth engine. So let's right-click and select Sort. And in this case, we're just going to go to Manual. We're going to say, all right, make sure that less than 50K is up on the top. Then 50 to 100, 100 to 500, 500K plus. We're good to go. And so we can rename this as LTG2UT, the lifetime gift, versus that wealth estimator. And we're done.